Alright, in this video I want to talk about something that's very important in algebra, not only algebra, but in other domains as well. This idea of a function is something that's also used a lot in computer programming and many other areas as well. So in this section we want to talk just about what a function is. What does it even mean for something to be a function? And then a couple tests that we can do to tell if something is a function or is not a function. So the general definition, the broadest definition of a function is you have a collection of what are called inputs and outputs. And the example that I like to give, I mentioned computer programming. The example I like to give is a computer. When you have a computer in front of you, you can think of inputs like when you tell the computer to do something. So let's say you hit Control Alt Delete. That's an input that you can put into your computer, and the output might be something like your computer restarts or you pull up the task manager. Okay, another input might be that you press the enter key, and an output might be that a program opens. So that's what we mean by input and output. Input is something that you do, output is something that occurs as a result of your action. Usually the way that functions work is that the input is symbolized by an x value and the output is symbolized by a y value. And the term that's used for the set of all possible x values, that's called the domain. I'll show you in a sec how to find the domain. The domain is all the different things that x could be. So a really simple example, suppose you had just these two coordinates right here, 1 comma 2 and 3 comma 4. Those are just two xy coordinates. We would say that the domain of that function right there is 1 and 3 because those are the set of all possible x values. And the range refers to the set of all possible y values. The range here would be 2 and 4 because those are the things that y could equal. So that's what we mean by domain and range. Okay, there's a test if you have a graph, basically. First of all, the definition of function is that each input is allowed to have only one output, exactly one output. And you can see why that would be useful with a computer. If you press Control Alt Delete and multiple things could happen, either your computer restarted or your entire hard drive got destroyed, that would be a big problem. I'm going to show you another example in just a sec where a problem could result too. Okay, the way that it looks on a graph, and like I said, this will be clearer when we do some examples, is that if you graph a function, you should be able to pass a vertical line through it only once. Okay, if a vertical line ever hits the graph more than once, it's not considered a function, and I'll show you a picture in just a sec. And then something that goes together with the idea of a function is what's called a one-to-one function. So in order for it's possible for something to be a function but not to be a one-to-one function. One-to-one function means not only does each input have only one output, but the reverse is true also. Each output has only one input. So that's why it's called one-to-one. One input leads to one output, and one output leads to one input. And the test for that on a graph is what's called a horizontal line test. So simple example, let's suppose this is our graph right here. This passes the vertical line test because I can draw a bunch of vertical lines and they're never hitting more than once. So that's considered a function. Okay. On the other hand, well, it's also, I was going to say, it's also a one-to-one function because each horizontal line only hits once. We'll see in just a sec some examples of things that are not like that. But here's a simple example of something that's a function that you're probably familiar with, the idea of a phone. The numbers that you dial in a phone are the inputs, and the outputs to dialing a phone are reaching people, right? When you dial a phone number, that's what you hope will happen. You hope that you're going to reach whoever it is that you dial. So let's suppose we have this really simple phone system here. We have 3 phone numbers. And obviously these are probably not real phone numbers. 1, 2, 3, 4, 5, 6, 7. And we have 555, 7 5s, and then we have 8675309. Okay, the question I have for you to think about is, would this count as a function? And you can see why obviously it would be important for phones to work as functions. If you dial a phone number, you only want to reach one output. That's what a function means. Each of these is only allowed to have one output. Okay, so right now, and hopefully you can see why this would make sense. Right now this is a function. Each of these 3 phone numbers right here is only reaching one person. 1, 2, 3, 4, 5, 6, 7, that only reaches my neighbor. The second number only reaches my brother. The third number only reaches my brother. So it is considered a function. It's a function, but it's not a one-to-one function. And if you're not sure why, look back at that definition. Okay, the definition says each input has only one output. Well, that's true. Each of these phone numbers only has one output, but each output does not have only one input, because my brother right here, my brother has two different inputs. He has his home phone number right there. He has his cell phone number right there. So that is not considered a one-to-one function, even though it is a function. Okay, let me do something that will make this not even a function. So now let's suppose I do this. I add a phone number, and let's say they program the phones wrong, and not only does 1, 2, 3, 4, 5, 6, 7 reach my neighbor, but it also reaches some random guy in Alaska, let's say. AK is the abbreviation for Alaska. I know some people in Alaska, so that's why I'm using that state. Right now this is not a function, because at this point I could dial that number and I could reach multiple outputs, so this would be considered not a function. So I want to go through a couple examples with you and ask 3 questions for these. We'll do these 2 right here, and then below that we'll do some graphs also. So the 3 questions are: is it a function? Is it a one-to-one function? And then what's the domain and the range? So based on the definitions we just went over, see if you can answer those 3 questions. Pause the video and try to work through those 3 questions on your own, and then we'll go through the answers. So number 1, is it a function? Remember, a function means each input is allowed to have only one output. So that input has only one output. This input has only one output. This input also has only one output. And 4 only has one output. So this is a function because each of those inputs only leads to one thing. It's not a one-to-one function though. Okay, and I want you to think about why this is not a one-to-one function, and hopefully it will make sense to you when I tell you why this number right here is an output that has multiple inputs. The number 3, not only does it have 1 as an input, but it also has 3, and that means it's not one-to-one. Okay, what's the domain? The domain of this function is 1, 2, 3, 4. It's the set of all inputs, or the set of all x values. Those are the 4 numbers that we can plug in from right here. And the range is the set of all outputs, which is 3, 4, and 5. Okay, that's coming from these 3 numbers right here. Alright, number 2, same question. Is it a function? Is it one-to-one? What's the domain, the range? And I put together these are 4 coordinates now, but we're going to put them in one of these. This is called a mapping diagram, by the way. Those 2 columns right there, we're filling it with numbers. Just a nice visual way to see what it looks like. So let's we'll put in 2, we'll put in 3, and notice that 3 is here again, so we only need to write it once. And then we'll put in -2. And the same with the y's. We'll put in 4, -1, 1, and 5. So 4, -1, 1, and 5. And let's draw our arrows now. So 2 is leading to 4. Okay, 3 is leading to -1, but 3 is also leading to 5. So I need to have 2 arrows there. And then finally -2 is leading to +1. Okay, now you could probably tell right away this is not a function. Okay, why is it not a function? Because each input is allowed to have only one output, and if you look at this input right here, this has multiple outputs. It has both -1 and it has +5. So this is not a function. Because it's not a function, it can't possibly be a one-to-one function. If it's not a function at all, it can't be one-to-one, because in order to be one-to-one, you have to at least be a function. Okay, the domain of this, it's not a function, but the domain, if we were going to write it, would be 2, 3, -2, and R stands for the range. That would be 4, -1, 1, and 5. Alright, let's try it now with those 2 tests I told you about, the vertical and horizontal line tests. So remember, a vertical line test means if a vertical line only passes through it once, then it is considered a function. If it passes more than once, it's not. Horizontal line test tells us whether it is a one-to-one function. So let's start with the VLT, stands for vertical line test, and we'll just go down the list, and in each case we'll tell if it's a function or if it's not a function. Alright, so the first one, is it a function? Well, you don't have to draw the vertical lines. I just want to show you how it works. As we draw vertical lines, right, and let me just straighten out these a little bit better so you can see these red lines is parabola. That's what that shape is right there. They're supposed to kind of go off like this. They're kind of drifting to the right and drifting to the left right there. So I just want you to see that it's not a straight line. So you can see every time I draw a vertical line, it's only hitting the function once. Each of these vertical lines, each vertical line represents an input. and each intersection point, so these blue dots that I'm drawing right here, each of those represents outputs. You can see each input, each vertical line has only one single output. So this is a function. It passes the vertical line test. Okay, next test for it to pass, is it a horizontal line test? Is it a one-to-one function? You can see I just drew that horizontal line right there. This is not a one-to-one function because those two dots that I just drew, those are both inputs, and this line right here is an output. A horizontal line is an output. It has multiple inputs, so it is not a one-to-one function because it fails a horizontal line test. Alright, see if you can pause the video and answer those same two questions about B and C. Okay, so B is asking us, is it a function at all? And the answer again is yes. Each of these vertical lines only hits once, so it is a function. Is it a one-to-one function? It's also a one-to-one function because each of these lines is only ever hitting at one point. So it's both a function and a one-to-one function. The domain and the range in each of these cases are both all real numbers, because if you look at that graph, x goes forever and y goes forever. X goes forever this way, y goes forever upwards, x goes forever to the left, and y goes forever downwards. Over here, by the way, we didn't add the domain and the range here. The domain here is also all real numbers because x is going to the right and left forever. The range is not, though. The range is all the y values that are greater than that number right there. So we didn't label it properly, but let's suppose on a graph -1, -2, that's approximately -3. So you could say y is greater than or equal to -3 as your range. Y could be any number bigger than that, but it doesn't go below that because all this stuff down here is empty. The graph never goes below. Alright, right here, is this a function? It's not, because I just drew a vertical line through it and it hit it in multiple places. So because it's not a function, it can't be a one-to-one function, so it doesn't really matter if it passes a horizontal line test. Actually, let me use a different color for that. So this, it also fails a horizontal line test, but it wouldn't matter anyway, because if it's not a function at all, it can't be a one-to-one. Okay, and the domain and the range we won't worry about in this case because it's a little bit hard to tell because the graph is not labeled with points. But the main idea is to understand the definition of function means that every input has only one output, and a one-to-one function means every output has only one input.